Okay, this is Dr. Williamson. I'm going to solve another problem using a neat little trick that I showed you earlier using kilograms. Here we're going to do some stoichiometry where our problem is in terms of milligrams. Now we're used to doing these kinds of calculations using grams. But what about milligrams? Well, I have to turn the milligrams into grams and then do what I know how to do, and then get the answer in grams and convert it back into milligrams. Was there an easier way? Well, what I want to show you is if we realize that if I have, I'll do it over here in red, 100, oh, excuse me. That's not what I wanted to show you. The molar mass I'll show you the trick with this here. The molar mass of the sodium bicarbonate is 84.007 grams per 1 mole. And the molar mass of sulfuric acid, H2SO4, is 98.079 grams per 1 mole. If I realize that if I take here, I'll do it over here, 84.007 grams per 1 mole. If I want to convert the grams into milligrams, this is that little trick I'm going to show you. I'm going to go 1 gram is 1,000 milligrams. We know that. Now, why would I want to do that? Okay, you'll see in just a moment. I also know that 1 mole is 1,000 millimoles. Why do I want to do that? Well, see here, moles cancel with moles, grams with grams, but the 1,000 cancels with the 1,000, and I'll realize that 87.007 grams, 84.007 grams per 1 mole is also the same thing as 84.007 milligrams per millimole, right? But it's also the same as 84.007 kilograms per 1 kilomole. Because the millis, the milli here with the milli there doesn't disturb the ratio. So now I can take my 100 milligrams here, milligrams of bicarbonate, sodium bicarbonate, NaHCO3 times, there are 84.007 milligrams per 1 millimole of the bicarbonate. And for every 2 millimoles of bicarbonate, I will need 1 millimole of sulfuric acid times, whoops, no, I don't want to move that. Don't want to move that. Move this out of the way. And let's move this out of the way. And then, oh, what I do, move my balance. Okay. What I do with my balanced chemical equation. All right, anyway, all right, fine. Let's see what I'm doing. Let's do this. Let's move these two pieces here. That's, oh, I don't know what the hell I'm doing there. Let's undo that. What is going on? Sorry, guys. There we go. I'll just move that. Okay. So anyway, back to what we were doing. And then here, 1, this is millimoles. 1 millimole of sulfuric acid weighs 98.079 milligrams of sulfuric acid. And I will see that grams here, that's milligrams, excuse me, milligrams here cancels with the milligrams. And I'll be left with millimoles of this, but the millimoles of that cancel. I'll be left with millimoles of that, but the millimoles cancel. And I'll be left with here equals, I bust out my calculator, 100 dot divided by 84.007 divided by 2 times 98.079, and to 3 significant figures, I will get 58.4 milligrams of sulfuric acid is needed. So I just got to remember that because of this, then 84.007 grams per mole is the same thing as 84.007 kilograms per kilomole, as long as I have the kilo on top and bottom. Same thing as 84.007 milligrams per millimole. As long as I have a kilo on top and kilo on bottom, milli on top, milli on bottom, centi on top, centi on bottom, it all works. Okay, so I hope that little trick helps, and sorry for the little, I don't know what was going on there. Okay, all right, I'll do another one later.